Check in the properties. The action type must be set to submit. It's fundamental because the jump is a single impulse, not a continuous value. Then below, in the binding, make sure you have assigned the space key for the keyboard and the south button for the gamepad. If this is not set, the code we are about to write will speak to a vacuum. Now, to avoid wasting time searching for files in folders, go to the inspector on Get Input, hover the cursor over the center of the component, and double-click Magic. Visual Studio opens up. Now let's prepare the switch that will communicate with the rest of the game. We write a boolean variable public bool jump input. This will be our switch. We need it to tell the rest of the code whether the button was pressed or not with true and false. Now we create a function. We call it jump start. And we assign it the value jump input equals true. And right below, when we release the button, we create the function jump stop and give it a false value. Now let's connect the events in onEnable. We write my controls pylon jump performed +, and we assign it the newly created function jump start. Do the same in onDisable, but with the minus sign to disconnect them. We do this because if the object were destroyed, Unity would keep trying to send the signal to a button that no longer exists, creating memory leaks, and we definitely don't want that. Now, let's save everything and move on to our player move controller script. We create the method directly creating a function that we call jump player. Inside, we write a check. If the switch is turned on, we give velocity to the rigid body. Hold on everyone. Unity shows an error on jump force. Let's go up among the variables and declare it as public float jump force. Now the error disappears. Now we call the method inside typeized. Let's go back to the method, and after the jump we write g input jump input, and we assign it the value false. This resets the input. If we don't do this, the player would keep jumping every single frame, as if they had the springs under their feet. Let's save and go to Unity. Let's turn up the jump force variable in the inspector, otherwise it won't move even with prayers. And let's test it. It works. Let's solve this with laser sensors. So now we need to tell the game who is the floor and who is the player. In the inspector, we go to layer, click add layer, and create a player layer and a ground layer, because we will assign one to our character and ground will be for our floor where we touch terra firma. Let's assign them right away. Now let's go directly to project settings, select physics 2D, uncheck ground and leave it checked only on player, while on player we uncheck everything. We do this to optimize the game, preventing the rays from colliding with the character's own body. Now let's select the object inside the player and bring it back from 90 to nil. This will be temporary. Select player and create two empty objects. Empty object, which will be children of the player. Rename it point left. Let's place it under the feet. Now copy and paste. Rename it point right and move it to the right foot. Position them properly, one on the left and one on the right. Why 2 points? It's for the raycast. If we use a single ray at the center of the body, what would happen if your hero found himself with 1 foot off a ledge? The ray would pass through the empty space and the character would remain stuck without being able to jump. So a bug would be created even if visually he still has the other foot on the rock. By using two sensors, we cover the entire base of the character. If at least one of the two touches the ground, the jump is guaranteed, and it makes the difference between a game that feels broken and one that responds to commands like a glove. Select the object inside the player and bring everything back to rotation at 90 degrees. Let's go back into the script and write the variables we will need to make our sensors work. So we write a variable of type float, we call it ray length. This is the length of our ray. Imagine it as an invisible tape measure that starts from the feet and goes downwards. A variable of type layer mask, and we call it ground layer. This is a filter. The ray ignores everything. It only responds when you hit the layer we called ground. Then a variable of type transform. We will actually create two of them. They will manage the right foot and the left foot, the empty objects we created. So they will be our starting points. They indicate to the code the exact position x ipsu roli, from where to trigger the laser under the feet. Then the last one, a boolean we call it, is grounded. This is our final response. It will be true if we are touching the ground, it's false if we are in empty space, like if we are jumping or falling into a ravine. Now we write a method and call it check status. Let's analyze what we are telling Unity word for word. So ik chest do the left hit, we are creating a container called left hit. Okay? So this container will store all the information about what the laser hits. Then we have physics 2D Rorch at. It's the command to shoot the laser. Then point left ball position indicates the exact spot where the laser starts. The left foot and then vector 2 down indicates the direction of the laser downwards. Ray length indicates how long the laser should be. If it's too short, it will never touch the ground. And then there's the last one, ground layer. This is a filter. It tells the laser, ignore everything else. Only respond if you hit the floor. And then we repeat the same line for the right foot. Now that we have shot the lasers, we need to interpret the results. We use an if statement to decide if the player is on the ground. We write if left hit collider null, then you see these symbols. It means or if there is one foot and the other is not and it's outside the ledge, you have to say yes. So the value is either one or the other, or both is yes, otherwise no. Now let's go update the jump. We create an if inside the if and write g input jump input. And we cut the function and insert it in here. And we pass the check status function into typefordice. Save. Select the player, and immediately in the inspector, in the ground layer script, we set ground. Now let's drag our created objects into our player point left and point right. The jump is solid, it's ready for release. Let's go back into the script, add this function, we write on draw gizmos or debug draw array. This is used to see the rays. We use debug draw array and set the color to green if it touches and red if it's in the air. We call this function inside check status. And let's go to the inspector. We set the values for the length of our laser. Let's activate our screens because we can only see it in the scene view. So we also need the command from the game view. Let's split the screens so you can also see how it works. Let's observe carefully. We programmers don't have X-ray vision. Without this method, we are coding in the dark, hoping that the sensors work. While with debug draw array, we have laser vision, and it's a fantastic thing that we can know where we touch. If it's green, it's touching. If it's red, you are airborne. If something is wrong, you see it with the naked eye. Without going crazy over 1,000 lines of code, very well. That's all for this lesson, and we'll see you in the next one with the jump animation.